In this video, I'm going to be covering oxidation states. When atoms interact to form a molecule, we can use oxidation states to keep track of the charge that each individual atom will contribute to that overall molecule. So when we assign oxidation states, there are a set of rules we need to follow in order to correctly assign an oxidation state for each individual atom. So rule number one for assigning oxidation states is that any atom on its own has an oxidation state of 0. So if we have an atom that is not interacting with any other atoms, that atom will have an oxidation state of 0. Rule number 2 is that the sum of all oxidation states for a molecule must be equal to the overall charge of that molecule. So if we were to have a molecule like CH3COO minus, we need to make sure that when we add up the oxidation states for all of these individual atoms, that they would add up to -1, which is the overall charge of CH3COO minus. Now we should note, as we go through these rules, we need to make sure that we understand that each rule is more important than the last. So rule number 1 is more important than rule number 2. And rule number 2 will be more important than rule number 3, and as follows. So rule number 3, all alkali metals, which are on the first column of the table, which include atoms like lithium and potassium, have an oxidation state of +1. Rule number 4 says that fluorine has an oxidation state of -1. Rule number 5 is that alkali earth metals, which are in the second column of the table, this includes magnesium and calcium, have an oxidation state of +2. Rule number 6 is that hydrogen is equal to +1. Rule number 7 is that oxygen is equal to -2. So going through these rules, we know that any atom on its own has an oxidation state of 0. The sum of all oxidation states for any molecule must be equal to the overall charge of that molecule. And then going through the table, we just need to make sure that all alkali metals have an oxidation state of +1. Fluorine has an oxidation state of -1. The alkali earth metals, which are on the second column of the table, have an oxidation state of +2. Hydrogen has an oxidation state of +1, and oxygen has an oxidation state of -2. Now, in following videos, I will go through how to assign these oxidation states when we are given examples. We need to make sure that we follow these rules in order. So if we have a molecule with an alkali earth metal and oxygen, say, we need to make sure the alkali earth metal follows its rule before we assign oxygen a state of -2. So what I mean by that is that we need to make sure that each rule is following its importance on this chart. So rule number 7 might have to change if we have to follow rule number 3 before it. So in the following videos, I'm going to be going through how to assign oxidation states for given examples.